in, right? That's the first thing we do. Go to your y equals. Type it in exactly the way it is with brackets and all. So it's x minus 8, x plus 15. Okay, type that in. Make sure all the plots are deselected. If you have them on, you're going to have issues. It will complain. There is a conflict there, which I will talk about later. Got it, right? Don't use times, use X, the X button. So you've got that. Make sure your calculators are fully charged. This one is going to drain your battery a lot if you do homework. Okay. Then what I do next? You can hit graph and see what happens, but I just tend to go zoom standard. Zoom 6. Right? Zoom standard is zoom 6. And see if it does anything for me. Doesn't really do a good job. If this does a good job for you, leave it. Don't do zoom fit. Just leave it. But it doesn't do a good job. One thing, before you graph, I need you to know this. What form is this in? This is not the vertex form. This is factored form, yes. You know what? The most important thing I want you to remember, it's not general. For now, if you know this can't be general, why is it not general? Because there shouldn't be any brackets there if it's in general form. Opening, which way is this thing supposed to, or what are we predicting it to go, up or down? The legs, are they going up or down? A is right there. And A is positive. So I'm expecting it to go up. Okay, that's one thing I need you to know, because sometimes students type in the equation and it's going the wrong way and they keep going, right? They just keep going. It's like, wait a minute, it can't be. It should be going up. The width, this one isn't as important to me, to be honest, because the calculator will take care of that for you. But if A is equal to 1, we kind of call that like a normal width. It's not going to be crazy. It's not going to go like super wide and then go up. Or it's not going to be super narrow, like almost like going straight up. It's going to be like a normal shape. That's kind of what you need to expect. And then the y-intercept and everything else we can kind of do, we can just do that with our calculator. So I'll leave that for now. But these three things I would expect you to just get them like that just by looking at it. Okay? So we tried to graph it. It didn't do a good job. I know it's supposed to look like this. So this is one of the legs that you caught, and you know that it's going down like this, and somewhere it's going to come back up. We just don't see the other leg here. Try zoom fit. Let's see what this does for us. Zoom, and I press 0. Zoom 0 is zoom fit, right? It does a bit of a better job, but not quite yet. I need to chase the curve. So we know we need to do what with this? This is determined by X min in our window. So we got to go to window, X min, we have to go negative. I'm going to go negative 50. It's overkill. Negative 50 is too much, but it's okay. It will work for you. So because I can't help it, I'm just going to say negative 30. That's a little bit better. It's a bit more centered. The vertex is awfully close to the edge of the screen. It could get you trouble. It could get you in trouble. So we're just going to go window and then Y min. We're going to reduce that a little bit. So I'm going to go negative 150. Hit graph again. So now this is a perfect view. You have everything there. Let's find what we're missing. For the y-intercept, I'm going to use second trace value, comma, x is equal to 0. Second trace value, x is equal to 0. Hit enter. It's 0, negative 120. Don't forget your signs, okay? There we go. The vertex. Oh, I'm out of lead. Vertex. What is this, a min or a max? Min, yeah. Second trace min. second trace minimum. That is I need to go to the left of it, enter, to the right of it, enter, and then enter again. Why does it say guess? Literally, it wants you to guess a point. Just give me anything. That's why we hit enter, and that's the one we submit, okay? The vertex is negative 3.5, negative 132.5. So these numbers are bigger than what we're used to, perhaps. But there it is. Got my vertex figured out. Axis of symmetry. What is the axis of symmetry? It is an equation of the line that cuts it in half vertically. So it's given to me by the x value of the vertex. The equation of the minimum or max, you picked minimum up here. That is a giveaway that it should be minimum. That is an equation that is horizontal. Its y is equal to the y value of the vertex. There we go. These are imaginary lines. You just get them, right? You go straight from there and there. Okay, that's how we got it. X-intercepts, how many are there? The graph tells me there are 2. Okay? So what do I do there? I will tell myself what I do first. Y2 is equal to 0. Second, trace, intersect. And I don't tell you this in you don't have to write this down. Then just press enter 3 times. Okay? That's what you need to do. You need to press enter 3 times after performing those steps. So I go y2 is equal to 0. I hit graph. There it is. Then I perform these steps here. Second, trace, intersect. I go to this one because my cursor is closer to that one. Enter 3 times. That's negative 15, 0. Second trace 5 again. Scroll all the way over to the other side. As soon as you're a bit closer to that one than the other one, you can just press enter 3 times. It's going to find it. That's 8, 0. Does anybody see these numbers elsewhere? Look at the equation. Let me see if I can fit. Don't you see 8 and 15 there? There's also 8 and 15 here. What's the only difference? It's negative 8 there. And what is it over here? It is positive. And it is positive 15 there. What is it here? Negative 15. If you notice that pattern, folks, just by looking at this equation, you could have figured out your x-intercepts. Okay, just like that. So if you notice that, go for it. Now let's graph. Sketch it. So if you want full marks, make sure there are arrowheads on your axes. And for now, it's just x and y. Okay, just x and y. Now you need a scale. Look at your x-intercepts first. You're going from negative 15 to 8. That's not too bad, is it? So I'm just going to say this is negative 5, negative 10, negative 15. This is what you're going to do in a minute. I'm going to go negative 20. So I'm going by 5s, and I will go 5 this way as well. 5, 10, 15, good enough. So every box is worth 1. It'll be very easy to graph because of that. Now, you look at your vertex and the y-intercept. The vertex is at negative 5, negative 132. So it's somewhere here, and it's going to be way down here. And I have to make sure that fits. So I think I'm going to go negative 50, negative 100, negative 150. I think that's going to work very well for me. So every box is worth 10. I do the same thing going up. Okay, so different scales, but they're consistent within the axes, and you're fine. Let's plot. X-intercepts first. 8, 0 is 8, 0 is right there. Negative 15, 0 is right there. So if you can be right on it, do it, okay? Then I have my y-intercept, which is 0, negative 120. That is right there. Then I have my vertex, negative 3.5, negative 132. So I'm going to try my best. This is 130. 132 is right there. So I have 1, 2, 3, right? I have 3 points that help me on this right side. And this is the art of graphing. You got to kind of develop that art. You don't want to go, it's not connect the dots like you normally would. It's curve, right? You got to curve it and then just make it look like that. It just keeps going that way. And then from here, you want to make it look symmetric. And there you go. My art teacher would now be very proud of me. Back then, not so much. X minus 8, x plus 15. So you always label it with the equation, always. Okay, if you want full marks, make sure you add that to your graph. So one more time, for a good graph, we should add this to the front. I will add this to the very front because you're going to do a lot of graphing. So that's like study sheet entry. If you're still copying this, go for it. In the very front, I'll just have a little corner there, graphing, like what needs to be on a graph every single time. Okay? This is like based on the provincial exam already for next year. So if you keep this on your study sheet, by the way, don't throw out your study sheets. Keep them for grade 12. There's some parts that you can reuse, especially the graphing part. So a good graph has, right, scale. It has to be consistent. Labels and units. Example, right? Time in seconds. So down the road, X and Y axis is not just going to be X and Y, it's going to be time versus height, right? Or you're going to compare different variables. Money over time. Things like that. Labels, scale labels, and appropriate shape. By this, I mean the points need to be where they should be. Like if you make your graph and the points are way off, you lose marks for that. So these are the things that we're always looking for. And by labels, I also mean the equation, right? Should I have that as a different? I will add that as a different, like a separate, because that's kind of like the last thing you want to do, because otherwise if you put it down right away, you might cross it off with your graph, right? So at the very end, add your equation. So these are components for a good graph, okay? Good?